So I wanted to do a video on at least a couple of the problems out of the packet so that you have something to refer to. So the first one I'm going to do is number one. It's a horizontal velocity, straight out you're throwing a football. The question is, how long does it take to hit the ground, and how far from the base of the school does it hit? The instructions also mention that you're going to need to do these 4 things to get the full credit. So the first thing we're going to do is construct our picture. So our picture is going to look something like this. We've got our building, ground, and football straight out. I'm going to draw that vector. That straight across is 12 meters per second. This is this here is 30 meters high. So I'm going to say this here is our, we'll label it D for distance. And I'm not going to worry about labeling time here. So constructed the picture, showing the window. So as far as that goes, showing your window with labels, I'm just saying that this is our x-axis label and our y-axis label for our window. So our window and the y-axis we're showing 30, and the x-axis is our unknown, so that's our D. So let's get to work on our vectors. So we've got a simple problem like this where there's no wind, we're not shooting it at an angle, it's just a straight horizontal force. We go back to the idea that x1 consists of all horizontal velocities multiplied by t. So in this case, all we have is our 12 meters per second times t. So that's what we put over here in x1t. As far as our y1 goes, there's no vertical velocity on the football, but we do start, like our y-intercept is 30 meters. So we're going to start 30 meters up, and from that, the only force, the only vector that we have is the force of gravity. And in our case, we'd write that as 4.9 t squared with a subtraction. Subtraction means the vector is pointed downward. Gravity is pulling down. 4.9 because we're using metric, we're in meters per second. If that was feet per second, that's like in class today, that 4.9 becomes negative 16. So that's what we can put in y1 as 30 minus our 4.9 t squared. So those are our 2 equations, our 2 parametrics, 12t and 30 minus 4.9 t squared. After that, what we're going to do is put that into our calculator. I've actually already done this one, so let me clear it out. So we'll go back. x1 was just 12 times t. Our y1 was 30 minus 4.9 t squared. Okay, got it. With our window, let's look at our window for a minute. The first thing it comes up with is t min max, t min, t max, and then t step. So t represents time, so we need to start our time at 0. Our t maximum, we've been using 10, but if you've noticed, all of our problems end up being less than 5 seconds long. So I'm gonna shorten our t max to 5, and then we always start our t step at 0.1. So we'll plug that in, and then our x min max. X is just a horizontal distance from the building, in this case the top of the school. So we always start at 0, and our x max, this is the one, it's going to be our unknown, that's our D. So we don't know what to put in there right now, but for now I'm going to put 100. That's usually a safe bet. It just kind of depends on the context of the problem. And then our y min, y max. Alright, so here y is our vertical distance above ground, so we're going to start at 0. for the window anyways. And then we start the problem 30 meters above ground, and then we shoot horizontally. We throw the football horizontally. So we know that we'll never get above 30 meters, so we'll make our y max 30. From there we're going to go t min, t max. I will start this at point 1. And if you notice, our x min and x max, I had it 40, but again I'll put it at 100 for this one. And our y min, y max is 0 and 30. Alright, so you're going to graph that. And what you see is that our graph is, I mean, it's all there, but it'd be kind of nice if we could zoom in a little better. So what I'm going to do is change that y max, or x max, to what it was a minute ago, 40. And notice all it did was change the slope. Didn't change our values. So what we're going to do here is, we're being asked in the problem, it says, how long does it take for it to hit the ground? So to solve that, we need to trace, and we know it's somewhere around at least 2 seconds, right? So I'm just going to skip right to 2. We're going to keep arrowing over with our trace. We're focusing on the y value. When does the y value, the above ground value, turn negative? And right there it was. So somewhere between 2.4 and 2.5 seconds. So the actual activity, the worksheet you have, it asks for time to the nearest tenth and distance to the nearest meter. Alright, so we don't know, is it 2.4 or 2.5? In order to get that tenth, what we have to do is change the window. We need to change our t-step to 0.01. Okay? So, in order to do that, once we change that, we go graph, and of course it's going to take a little bit because we're evaluating more data points here, 10 times more to be exact. Now I'm going to hit trace again, but this time I know we're between 2.4 and 2.5, so I'm going to trace right to 2.4, and then I'm going to arrow over. And what you see is that 2.47 we're positive, 2.48 were negative. So if we were to round our time estimate, we'd have to round up to 2.5. And then in the same respect, to the nearest meter, it doesn't matter whether at 2.47 or 2.48, you're going to round up to 30 meters. So time was 2.5 seconds. And our distance we found was, we had to round up to 30 meters. So just make sure to put those both in, square them off, whatever you need to do, and make sure you've answered both the time and distance. And we also want to make sure that we answered all 4. We constructed a picture, we identified our vectors, we labeled our answers, and showed all of our work. Labeling answers, I do mean label seconds and meters, or seconds and feet, or whatever the units are. Sorry, that kind of skipped there for a second. Anyway, just make sure you have all 4 of those checked off before you move on to the next problem. So that is number 1.